chemistry. Do you know about protons, neutrons, electrons, atomic number, atomic mass?
Yeah.
You get all that stuff?
Yeah. Well, I mean, I get it, but it's still confusing. But
So
like the bonding and stuff is confusing too. All the different bonding and how to know. Like if you see like a question about like one of the bonding, it's like, how do I know which one it is? You know. Like all the chemical bonding, hydrogen bonding.
So let's start with the super basics. Actually, I'm trying to think of. Let's just make something up. Let's say you have element X, and this number's 2, and this number's 4. Do you know what those numbers mean?
Is one of them the atomic number and one the atomic mass?
Yeah, do you know which is which?
Is the top one the atomic number and the
Yes.
bottom one the atomic mass?
So, do you know what the atomic number means?
It's the number of protons, right?
Yeah.
Which is also the number of neutrons. Or it might be electrons.
The atomic number is the protons and electrons.
The protons and electrons.
And actually, let's change our numbers here. Just for my example in a second. Atomic mass number, you know what that is?
It's the protons and neutrons.
Yes. So this number, so how many protons are made up element X?
2. Oh, 4. Sorry.
So I have 4 protons. How many electrons?
4.
4. 4 protons. How many neutrons?
4.
4. Because you know there's 4 protons, you subtract it from 8 to get the neutrons.
Mm-hmm.
You know, with any element. So you have your nucleus. So it's going to have your protons and neutrons. Oh, so does this have a positive charge, a negative charge, or no charge?
It is no charge.
No charge. Same number of protons and electrons.
Mm-hmm.
No charge.
Cancel.
So your first layer. Do you know how many electrons go in the first layer?
No.
The first shell? Okay. So 2 can go in the first shell. How many would be in the outer shell if 2 are in the first shell?
2.
2. Do you know how many an outer shell can hold?
I don't know.
It's an 8.
Yeah. So to be happy, it wants a full outer shell. Or, let me take that back. For it to be happy, it wants its outermost shell to be full. So you had some element and it only had 2 electrons. It's happy. Its outermost shell is full. But this one wants to be happy, so it's going to make 3, 4, 5, 6 bonds with something else to make it happy. Cool?
Mm-hmm.
And then for each shell, or sometimes it's called an orbit, I don't know what they call it in your test.
So it has 8 in there because the atomic mass is 8. Is that why there's 8 spots that want to be happy?
No.
Oh.
I'm explaining that right now. So your first shell wants 2. Your second wants or can hold up to 8. And your third wants or can also hold up to 8. And there's way more shells in this, but for this class, this is all you need to know. So just know, as you go out, the first one has 2, the second one has 8, the third one has 8.
Okay.
Cool? So be sure to know that. What else? Oh, that's important too. So, let's call it the rules of happiness. So once 8, outermost shell full, or at least an even number in the outermost shell. So this has 2 in its outermost shell, so it's happy. It would be happiest with a full outer shell. Do you know what an isotope is?
It's when there's, if I read it.
Definitely understand isotopes. I believe you're gonna be tested on your knowledge of that.
It's where they're like, it has like a negative charge, right? Or,
Not necessarily.
oh, it's just a different number of neutrons?
Yeah, there's a different number of neutrons. So so you can have, let's just use our element X. So the first one, which is 4 and 8. Let's say this one is 4 and 9. This one is 4 and 7. The atomic mass is all different, but they're still all element X. And every element has isotopes.
So only one of those isn't an isotope though? Like, or are they all isotopes?
No, so if this is normal, these would be isotopes of that element.